Alright, so this is Honors Geo section 7.7, solving right triangles. So if you were to have a right triangle, A, B, and C, if we had tangent of, let's use angle A here. Alright, so tangent of A, that's equal to opposite over adjacent, which is AC over, BC over AC. Then we have sine of A, which is equal to opposite over hypotenuse, which is BC over AB. Then we have cosine of A, which is equal to AC over AB. Jesus Christ. Well, we have something called inverse tangent, inverse sine, inverse cosine. And the symbol for that is tangent -1. That means inverse tangent. Sine of -1. And cosine of -1. All mean inverse tangent, inverse sine, inverse cosine. And what the inverse does is that it cancels out tangent. So inverse tangent cancels out tangent. Of course, what I do on one side, I must do to the other. And what happens is that I am left with the angle. I am left with the angle. So then I have the angle is equal to the inverse tangent of the ratio. Same thing down here. Inverse sine cancels out sine. So that angle A will equal sine inverse of BC over AB. And then inverse cosine would be angle A is equal to cosine of AC over AB. Alright, so inverse sine, inverse tangent, inverse cosine are ways to get the angle of a particular right triangle. Alright, they want us to find back in example 1. So for C, here is C. We have opposite and adjacent, so we can say that the tangent of C is equal to opposite over adjacent, which is 20 over 5. I'm sorry, not 5, 15, which is 3/4. So I can inverse tangent both sides, and I can say that angle C is equal to the inverse tangent of 3/4. And use inverse tangent, cotangent, inverse tangent, inverse sine, inverse cosine. It's right on top of your sine, cosine, tangent on your calculator. You hit second, and you hit the tangent, and that gives you inverse tangent, and you plug in the fraction or the decimal, and I got that C is equal to 36.87 degrees. Now, remember in the last section I told you to make sure that your calculators are set on degrees because you'll get wildly different answers. And this is the part where this is why. If I had C in radians, and I'm going to set it up and put it in radians right now. My answer would be 0.64. This is radians. And if I was in gradients, my answer would be 40.97 if I was in gradients. So, yeah, make sure that your thing is set in degrees because you will get wildly different answers. And, C for degrees and gradients are a little similar, but they're still, as you clearly see, widely off. So please make sure your calculator is set to degrees. Like, for real, for real. All right, d to the nearest tenth. So sine of d equals 0.54. Then to find d, I just have to inverse sine. So d equals inverse sine of 0.54. And d is equal to 32.68 degrees. All right. Solving for a right triangle. When you solve for a right triangle, what you're doing is you're finding all the angles and sides of a right triangle. So for this particular problem, it says we have a right triangle with a 40 degree, which means that the other guy is 50. Said that the hypotenuse is 20. So we're trying to find the other two sides. We already found the angles. Need to find the other two sides. So I can solve it two ways. I can solve it in terms of the 50 degree, or I can solve it in terms of the 40 degree. If I solve it in terms of the 40 degree, to find the sides, this is going to be, for x, cosine of 50 equals adjacent over hypotenuse. So 20 times cosine of 50 equals x. X equals 12.5 12.58. Now I could have also did it in terms of the 40, and I could have said, instead of cosine of 50, I could also have said sine of 50 equals opposite over hypotenuse. And I could have said that 20 times sine of 50 equals x, and I would have gotten the same answer. 12 point. It's slightly off. Oh, that's why, because it's sine of 40. My bad. Sine of 40 would have gotten me the same answer. Alright, sine of 40. Yeah, x equals 12.58. So I would have gotten the same everything. Actually, it's 12.8586. Yeah, 12.86. So this guy's a little off. 12.86. Okay. Same thing with the y's. So if I did sine of 50, and that equals to y over 20, opposite over hypotenuse. And then 20 times sine of 50 equals y. So then y equals 15.32. All right, and I could have done the same thing with cosine of 40, and it would have gotten me the same thing. So 20 times cosine of 40 equals y, and then y would equal 15.32. All right, so either way, that would have gotten you that. So in terms of the answer, we could have had the angles are equal to 40, 50, and 90 degrees, and then the sides would have been equal to 12.86, 15.32, and then 20. Okay. Last one, we have a little ramp here. This is 2 feet. This is 20, and x has to be less than 5 degrees. Otherwise, this thing is considered unstable. So we need to know if this guy could be 20 feet by 2 feet. Opposite hypotenuse, so we use sine. So sine of x equals 20 over 2. Opposite over hypotenuse, which is 2 over 20, which is 1/10. So in order to find what that angle is, x is equal to inverse sine of 1/10. And the inverse sine of 1/10 is 5.74 degrees. So that's greater than 5, so it is not safe. Can't use it. All right. That is this section. Hope you have a great rest of your day.